Hey everybody, this is Mike. Just thought I would showcase some of the vast power of Desmos you have at your fingertips when you're taking the SAT by demonstrating how to do a couple of different SAT problems. So as we can see here, we have a difficult SAT problem, and we also have Desmos open in another window. So what I'm going to go ahead and do is copy this equation that they give you in the question, and they're then going to ask you what the corresponding points are that, fulfill this equation. So let's go ahead and type that in. We get 3/5 x plus 3/4 y equals 7. Now, as you can see, all four of the answer choices have the same x values, 1, 2, and 4, and then they have varying y values. And in fact, all of the y values are unique. So all we need to do is pick one of these x values, type it into Desmos, and it'll create a vertical line representing that point, either x is 1, x is 2, or x is 4. And then the intersection between these two lines is going to be the y value for whatever that x value is. So let's type x is 4. Why not? All right, so we have a bunch of different possibilities here. So we can see when x is 4, I just hover the mouse right over this point, I can see that y is 6.133, so I can go ahead and make that a point. Now I can just go ahead and plug in all the values for x is 4 in each of the four answer choices, and whichever one matches is going to be the correct answer. So we've tried a bunch already, and then we have 92 over 15. So as you can see, the correct answer is the last one, because this value, 6.1333, matches this value over here when we plugged in x is 4, right? That gave us an intersecting point. But the point of all of this is look at how easy Desmos makes this. All you need to do is copy this equation that they give you, and then type in x is 1, 2, or 4, find the corresponding value by clicking on it, well, really hovering over it. You can also click on it, and then making it into a point so you can remember it, right? And then plugging in the other values to see which one of those is the correct answer. So anyway, pretty cool stuff, I think. All right. Let's get another one of these going on over here. Bloot. Bloot. All right. Here is another one. All right, so let's go ahead and clear out our Desmos. Okay. Starting over here, we're given the equation of a circle, and we're asked what is the radius of the circle. Okay, trick question. I was getting all excited because you can just type in the equation for the circle and it'll give you the circle, and then you could deduce what the radius is by just looking at the diagram. But we don't need to do that, because if you know your formulas, you'll know that the formula for a circle is, given that the center is HK, it's x minus h quantity squared, which means that whole thing that I just said squared, plus y minus k quantity squared is equal to r squared. And we know that, well, we don't need these, but we know that HK is the center of the circle, and R is the radius of the circle. So if you know that equation of the circle, then you'll know that it's set equal to R squared, and therefore R squared in this particular circle is 121, which means that R must be 11. So kind of a trick question, super easy. You don't actually need to go ahead and graph it. But you do need to make sure that you know this formula here, this circle formula. You need to know that. If the center is h comma k, right? Here, let's make it even prettier. There we go. Then, and the radius is r, then it's going to be x minus h, quantity squared, plus y minus k, quantity squared is equal to r squared. All right, let's move on. Another circle question. But this one is in a completely different format. I became really enamored of using Desmos to demonstrate how to do circle questions because it just makes everything so easy. All we need to do is type in this equation, 2x squared minus 6x plus 2y squared plus 2y is equal to 45. And there we get a beautiful little circle What is the radius of the circle? We zoom in a bit, zoom in, and then it'll probably tell us. I mean, I hope. Yeah. So here it's giving us the y value at one end of a diameter of the circle, and then it'll give us the y value at the other end of a diameter of the circle. So you can see we have the y value here at both ends, and I just translated those into points by hovering over it, and then, well, it doesn't do it now because I already did it, but if you hover over the point, then this little notebook looking thing pops up. You click on that, and it makes it into a point. Anyway, we know that the y value here is 4.5, and the y value here is negative 5.5. So 4.5, right? 4.5 minus negative 5.5 is equal to 10. So the diameter is 10, trick question. The radius must be equal to 5. Okay? So interesting, super easy way to do this question using Desmos. So hope you got a lot out of that, and I'm going to go ahead and post some more of these just because I'm so fascinated with how incredibly powerful Desmos is when you use it on appropriate questions on the SAT.